So good morning. I'm Olivier Baverel, and I'm a professor at the School of Architecture of Grenoble and a researcher in the laboratoire NAVIER, which is within the École des Ponts Paris Tech, and I'm also a professor at the École des Ponts. So I'm going to do a short introduction about structural innovation, and after I will be chairing the session. Okay, so when we speak about structural innovation, we can wonder why doing structural innovation? What for? Well, in my opinion, it's mainly a question of sustainability. If we look at our consumption of any materials or resources on Earth, we're growing exponentially, and obviously we have only one Earth, and there are real limitations. So that's why we are looking for structural innovation to get more sustainable construction. So if we look now in René Zmotro's diagram on the morphology, structural morphology, you look at, there are five items: technology, form, forces, structure, and materials. I just make one comment. What I mean by structure is the arrangement of components, grids, pattern, hierarchy. For forces, of course, it's the external forces, the pre-stress, and also the structural response. And of course, for the technology, it's the fabrication and construction process. So, how can we make a structural innovation? It's very often by taking two of these components in a different manners and to get a resulting innovating system. We can look through a historical example. For instance, Félix Candela, who was a great high-power builder, he managed to mix technology and form in a very interesting manner. He built his formworks mainly with straight planks, and that, as a result, he did a wonderful structural innovation, getting very efficient high-power structures. On the other hand, Fraiotto was also a great researcher that we all know. And well, he managed to get force and form, a good combination of force and form. And well, when I speak about forces, it's mainly due to the development of this force density method that you may know. It's allow you to get a linear system of equation of a nonlinear system. And this has a permit in the 70s to be able to do this sort of well-known realization. Thinking about what we've been able to do recently is rethinking a space wooden truss. You know that wood is very difficult to assemble, and especially when you have beams that are connected to a beam, you need a steel assembly, and it's very often more costly than the wood that you're using, or even in terms of weight. Sometimes in a space wooden truss, you have more steel in terms of weight than wood. So we were looking at the technology and materials, and the question was, how can we spread the connection from a point to a line? Okay, and when you see the latest development in wood technology, it's mainly CLT systems that more or less take this way of thinking. But our answer was different. And here you see all the colleagues and institutions that worked with us. So they were technician, higher technician, and of course the École des Ponts, NAVIER, and the School of Architecture of Grenoble. And here is the result. So here you see the space frame. You see the main problem of a space truss structure is to transmit the shear force from the lower layer to the upper layer. And here the answer is to do paraboloid hyperbolic system, and that spread the connection from a point to a line. So this is using only small diameter screws, and with no heavy, complex steel system to make the assembly. So here's some views. So here's some detailed views. Okay, I carry on another example. Another example which is quite interesting is to revisit stone system, and it's mixing structure and materials. And it's mainly the work of my dear colleague Maurizio Brocato from the Laboratoire Géométrie Structure Architecture from École d'Architecture de Paris-Malaquais in central Paris. So he revisited a patent made by an engineer called Abeille in 1699. So now it's in the public domain for 300 years. And here you see another way to rearrange cubes and to get bending capacities compared to a simply stacking element on top of one another. So here's his recent construction made in Jericho with the architect Anastas in Palestine. And it's a wonderful structure reusing the Abeille system with a modern way to cut the stones and also to glue them. And another example from Maurizio Brocato, he called it the shark jaw shaped beam. And if you used to do structural mechanics, then you can obviously see that the stone is retaking shear force and the compression force. And of course, the rebar is still there to take the tensile forces. So as a last example, there's always the question of if we want to be sustainable, the question of upcycling. And the idea was to say, well, what can we do, for instance, with bicycle wheels? And we had, within the School of Architecture of Grenoble, we had an interesting answer. It works quite efficiently to take bicycle wheels, once again to take the shear forces that are within the beam here on the two supports. And the last example that you may have seen already is what can we do? You know, Grenoble is in the main town of the Alps, so we do a lot of ski. And the question is, we put in a bin 300 kilometers of ski per year, well, in the French Alps, but I'm sure in Switzerland it is even worse. And what can we do with it? And this was an answer to the geodesic dome. And I know some of my colleagues from EPFL did a great job this year. We were, well, having tries on this topic from 2005. And so last, if I try to conclude on this topic of structural innovation that we will spend this morning on this topic. And if we look at Montrose diagram, we look, obviously there's a huge change in technology nowadays. Things are going very fast. And maybe it's one of the main items, but maybe not, because it has consequences on materials, and at the end on structure, and on forms, and on the forces and structural response we can achieve. So all these 5 items are really closely related, and we will see through diverse examples this morning that these are the sources of structural innovation. One last word, to do structural innovation is good to publish. Sorry for the self-advertising. And there's a wonderful journal for publishing your research on structural innovation, which is a Space Structure, International Journal of Space Structure. It's run for 34 years now. It was set up by Professor Nushin. Well, that was one of the first researchers in 1984 who started to do configuration processing and something like a grasshopper in its own way at that time. And he did the design of the Heathrow Airport in London and many other things. And he was a pioneer at that time. So if you have an interesting contribution, please send your papers to this journal. Okay, so I have finished my introduction. So now I'm going to leave. Thank you.